So it says here, which similarity statement can you write relating the three triangles in the diagram? Okay, so I'm going to draw this triangle. Actually, I'll write the question here first. Which can you write relating the three triangles in the diagram? Okay, so this is which similarity statement can you write relating the three triangles diagram? I'm going to draw out my triangle here. Have something down the middle, right? Like so, and this here is a right angle. And then this is a V. This is a W. On this here is also a right angle. This is a T. This is a U. Okay. So it says, what similarity statement can you write relating these two triangles? Again, take a moment to think about this problem here. Maybe I'll redraw. Maybe I'll use blue to signify my letters here, so it's not as confusing. So there's 2 T, U, V, and W, and I have a right angle between the bisecting point here, and then a right angle within these two triangles. So what similarity statement can you write relating the three triangles in the diagram? So what I would do is, because we're not given any side lengths, I would focus here on the angles itself. So focus on the angles here. Let's take a moment to think about this problem. Or maybe I'm going to write down the logic here. Since no side lengths are given, focus on angles provided. So since no side lengths are given, we would focus on the angles provided, right? So take a moment to think about this problem again, and then we'll take up this answer as a group. All right. So how we would solve this problem would be, since no side lengths are given, focus on the angles provided, right? So let's look at the angles here. I'm going to do this in red. So we have a 90-degree angle between these two triangles, right? If you think about this triangle, there's triangle 1 here, or triangle TUW, and also triangle UV, or UWV, right? So let me do a UVW. Okay, so you can think of this right angle triangle here as 90 degrees, right? And you can think of this angle, it distributes evenly to two 45 degrees, right? So this angle here is 90 degrees. It's a right angle. We're going to divide it by 2, right? Because it's split this angle. I'm going to split the two triangles evenly, right? So I have one angle here and one angle here as well. Here as well, which means it's 90 degrees divided by 2. So it's 45 degrees for this angle here. So this angle is 45. This is also a 45 here, right? So this here is here is my angle. And again, here I have a right angle at U, right? So which means this is also a 90 degrees angle, right? 90-degree angle. So therefore, what I can do is I can actually solve for my missing length, my angle T here, right? So I'm gonna solve for my angle T. So I can say that angle T equals, I would equal the sum of the interior angles of a triangle, which is 180 degrees, minus, I'm going to have 90 degrees here, minus 45 degrees here, right? Which means the answer should be 45 degrees. 180 minus 90 is 90, 90 minus 45 is 45, which means this angle here is 45, right? And I'll do that in red. This here is 45 degrees, right? Oh, sorry. This here is a 45 degree angle, right? So now I have three of my angles that are I have three. I solved for three of my angles, right? Which is awesome. So now, what kind of similarity theorem could I use to say that to relate these three triangles in the diagram here? Remember, I have three triangles, right? I have two. I have one here, and one as a big total, right? Oh, so this is a multiple choice question. I lied. Oh, I thought it wasn't a multiple choice. Sorry. Okay, so maybe I'll readjust my thinking here. So let's look at the first one here. It says T. Actually, let me do this in blue. From A. So from A here, it says that triangle TWV is similar to triangle WUV, which is similar to triangle UVT. Okay, so let's look at this one here. So it says here TWV. So TWV, so this big triangle here, is congruent to WUV, which is similar to UWT. So that's here is my first one here. It's this big triangle is similar to this one here, and it's similar to this one here. So that's here is my first triangle here. That's my first statement here. And let's look at B here. B here would be triangle UVW is similar to triangle WUT, which is similar to WVT. So this is UVW is similar to WUT, which is similar to WVT. So in this case, it's just the same. It's the same triangle, but they're using it in a different order, right? And they're writing these triangles in a different order here. And then finally, or let me write this down. I have C, which is triangle WUT, similar to VUW, which is similar to triangle UWT, right? So WUT is similar to VUW, which is similar to UWT. So this C here is incorrect here because I'm restating my triangles, right? So if WUT is this first triangle here, VUW is my second triangle here, and UWT is again my first triangle here. So in this case, the C is actually the incorrect answer here. So I can cross that out because it's stating the same triangle twice. I have D is triangle UVW is similar to triangle UWT, which is similar to triangle WVT. So this is, again, UVW is this top triangle here, UWT is this bottom triangle here, and WVT is the big triangle here. So A, B, and D all incorporate these three triangles. So let's look at the solution here. It says option D is the correct answer. So it says here, use the theorem if the perpendicular drawn from the right angle of a triangle of the hypotenuse to the hypotenuse, then the triangles on both sides are similar to each other and similar to the whole triangle. So it says if the triangle drawn from the right angle of a triangle to the hypotenuse, then the triangles on both sides are similar, right? So if I'm drawing a hypotenuse, I'm drawing this here. A perpendicular is drawn from this right angle here, from this right angle at W, to the triangle to the hypotenuse. Then the triangles on both sides are similar and similar to the whole triangle. So this here, this line defines my the perpendicular here. So let's look at their explanation and let's see if it's good. So it's saying that A here, since angle U is 90, angle U here is 90 in VUW, but the corresponding W in UWT, corresponding W here in UWT is not equal to 90. So they're taking these two angles and they're saying angle W here is not angle, it's 45 actually instead of 90. So it's incorrect, which is great. Incorrect since U90 here in UVW. So in here, UVW, but the corresponding W is not equal to 90, right? Again, this here again is 45. C, we already talked about this logic here. It's talking about the same triangle. And D here, because it's corresponding, right? So let me look at D here. And D states that UVW, so again, UVW is correspondent to UWT, which is correspondent to WVT, right? So we have the right angle here. We have the right angle here, and this here bisects, or the perpendicular between here is also 90 degrees, right? I have angle W, the big W here is the entire triangle here is 90 degrees. This is also 90 degrees, and this is also 90 degrees. So option D here is correct. So this here is the corresponding angles are equal. Therefore, by AAA theorem. So we're using, actually, this is AAA theorem, and the solution didn't state this. So it's because the question asked what theorem are we using, right? Or what similar statement can you write? So actually it's by AA theorem. So we can say that D is correct. So good solution and logic. We are using a theorem we're using so we're using if two of the angles are the same, if two of the angles are the same, the third angle is the same, and triangle is similar, right? So to prove similarity. So